Go!
Hello everyone, welcome to Practical GCP. Today I have a very interesting topic to present, which is about getting Kafka events, right, from your Kafka cluster, specifically from an on-prem or on a different cloud in the Kafka cluster, to get the events into your Google Cloud ecosystems, to land the data into the pubsub message queue and also into BigQuery, right, by using some of the Google stack or the Google technologies. This is important because this stack really unlocks you to start building your downstream pipelines or other applications using the Google Cloud ecosystem, right? If your data sits on Kafka or sits on a different cloud, a different environment on-prem, there's not much things you can do on Google Cloud by utilizing that stuff directly. It's just so complex. The integration ecosystem isn't that great. But by getting the messages, or what I call it is relaying your messages into the Google Cloud ecosystem, it can unlock a lot of these potentials. So I'll cover a number of topics. To start with, I'll talk about what is the problem, right? And then why we're talking about the pubsub first design. So instead of saying this is just get data into BigQuery, why we talk about pubsub first. And then I'll talk about this thing I've created. I'll show you exactly why I'm doing this with this Kafka Relayer in more detail. Once the data is in pubsub, there is a very simple thing you can do to get data from pubsub into BigQuery, which I'll show you one of the specific Google provided template that you can do this in a very straightforward way. And then, as always, I'll show you the code example and demo the use cases on exactly how this is going to work in reality, right? So let's crack on. So first of all, let's look at this architecture, right? So the first of all, you have the Kafka cluster. This sits on your on-prem network, or you can call it the legacy infrastructure, or the stack that's not on the cloud, or it could be on a different cloud, right? And this thing in the middle is the Kafka Relayer I was talking about. And as you can see that the solution involves getting the Kafka Relayer deployed on your on-prem infrastructure. This is actually really important because in a lot of the scenarios on the companies, it is quite difficult to try to tap in from like the Google Cloud side into this Kafka into this Kafka cluster directly, right, from the cloud. If you try to go backwards, there's a lot of network challenges, and it also doesn't actually give you a lot of flexibility in that sense. But usually if you have Kafka, you always have like virtual machines, right? You can deploy these services in this use case called Kafka Relayer onto your on-prem infrastructure. And this is not actually a very heavyweight service because all you're doing here is relaying the messages you've got the Kafka side on the Kafka cluster into another Google Cloud service. So this push pipeline, you can either use the interconnect from Google Cloud to send the messages privately, or you can use a VPN, right? So it's quite standard setup that allow you to have this kind of communication. This thing is very important because it is not one of these things require you to have auto scaling and all of this stuff. It's quite lightweight in the sense of all you're doing is to consume the messages from the left, right? Maybe do a little bit of enrichment, but you're not going to do that much. And then you straight away forward that message on. You're not doing any storage. You're not saving anything. It's all about just relaying the messages. So this is a important thing because the message now goes into pubsub, right? This is really, really key. The reason for the message to go to pubsub first is that so let me show you something first. On the Google Cloud template page, right, there is actually a Google Dataflow template called the Apache Kafka to BigQuery, if you can see in here, right? So this thing I did actually try it myself. It kind of works, but it's like the issue I mentioned earlier. It's quite difficult to tap into depending on the cluster you have, right? Some of these clusters have credentials requirement. This template would simply not work. And the others, you may have a network issue that it would be difficult to unlock, right? If you try to go back in on-prem, sometimes it's just a lot more complex than trying to push into the cloud. So, but the bigger issue is if you just use Kafka to BigQuery, especially this specific one, you can see it doesn't actually send the message into a message queue. So all the options you left if you do this is the data is going to be sent into an analytical database, which is what BigQuery is. And then what you will lose is actually quite significant, is all of the real-time subscriber use cases that you can tap into the pubsub subscription here, right? This is what you can see. The message lands on a pubsub topic, but these subscriptions, in this particular case, I'm using it to get data into BigQuery, but also those subscriptions can be used for whatever use cases that you have a real-time subscriber, such as when certain events arrived, right? You want to do something immediately, right? This is not something that you can do with BigQuery, right? Just keep in mind, it's really, really important. Kafka is a message queue, right? It's a message queue, it's a message broker. It's primarily designed for downstream real-time subscribers to make some decisions, right? Do some real-time use cases. If you send it to BigQuery straight away, you lose that main capability and it becomes a second-class citizen. But if you relay the messages into pubsub, you're not losing anything at all, right? It actually gets better because now it's in all of these messages are in the Google, in the GCP ecosystem. Okay, so once the messages are sent to the pubsub topic, keep in mind pubsub has two parts, right? Topic is the place where you receive the message, and subscription is the place where you would consume those messages. The reason there's three of them, they're actually the same thing, right? But the deployment, you would first of all create a subscription for each kind of the message types, right, you want to consume. Keep in mind, in the topic, you might have lots of different kind of messages, right, from Kafka. So Kafka also has the concept of topic. It's the same thing, but you could have multiple topics from the Kafka cluster relayed into the single topic in pubsub for simplicity, right? But later on, what's interesting is when you create the subscriptions, you can filter the message to the specific message type you want to use, because downstream BigQuery must have a schema, right? So if you have the schema of one type of message, I'll show you example later on, then this pipeline would go to one table. As you can see, subsequently you have table B and table C. So each of those pipelines that you can decide which message you're going to put into which table. And this design allows the maximum flexibility on real-time subscription use cases using the pubsub token, and also with other use cases that would give you the analytics side. Obviously, you can build a system to relay all of these things automatically and split the message into different tables. What I'm showing here is just like a really simple way that you can do this really quickly. So this whole solution took me about 10 hours in total to put this all working end to end, including some of the complexity on the Kafka relay, so I'm going to talk you through about it. This is probably the most important part because some of the complexity Kafka has. So in order to understand how the relayer works, right? So the first thing you need to understand is how Kafka works. So a lot of you may have some knowledge of Kafka. For the ones who don't know, I'll cover some of the fundamentals of Kafka and how it works using this diagram. In this case, so if you have a look what we're talking about here, from a high level, you've got systems that are sending events into a Kafka topic, just very similar to what you use pubsub for, right? And then the way Kafka works is each topic would have one or multiple partitions. So the way this works is each partition, so think about in a distributed environment, right? So in order to scale the amount of, the CPUs, the RAM, the storage, that you would need to partition your data somehow. So each of one of those partitions can physically exist on a different server. So that's what the partitions are for. So each topic that you send the data to, but actually behind the scenes is storing this data in different partitions, right? That's how you can evenly distribute your data. Let's say in this case, we have five partitions, starts from 0 all the way to 4, right? And then one of the really important things that you have to remember is there is a thing called offset, right? The offset is something that records where the consumption of the message is got to, and then that is at partition level. So on the right hand side, you can see I've got 3 consumers here, right? Consumer 1, 2, and 3. Those 3 consumers, you would have to manage the offset of your consumption of the messages to make sure you don't lose the messages, right? So, and that is managed at topic and partition level. So it's not just topic level, keep in mind, it's topic and partition. So let's say here I've consumed up to 100, here is 125, here's 20, there's 25 and 50, right? Each one of them is completely independent from the others. So when you use consumers, each partition can only be attached to one consumer. So in this case, you can see partition 0 and 1 is attached to consumer 1. If you have the 2 and 3 is used by consumer 2, and then 4 is consumed by consumer 3. So then you don't have conflicts, right? So if you deploy another one, this would further split, but you never end up with the use case that one partition is consumed by 2 consumers, which is never going to happen. So this is how you scale, right? So if you deploy consumer 1 onto one server, consumer 2 to another, then this is how you can scale your systems. So keep this in mind. This is really important to understand for the things we were about to show it later on. And just a little bit about this Dataflow template. The Dataflow template is something you can easily deploy. So the one I'm referring to, if you look at the same page, is the thing at the top, right? So this is the pubsub subscription to BigQuery. It's, again, really straightforward to deploy. And then one of the key things to remember is this is a streaming service. So it doesn't track the data into cloud storage bucket first and then put it into BigQuery. So it's actually just what it does is a streaming inserts into BigQuery directly. So the data is actually almost near real time. So we're talking about like a seconds latency all the way from the consumer side, the relaying side from Kafka to BigQuery. It will be seconds, right? At the time you can actually consume the data. But again, that's not for real-time subscriber use cases, which is for activation or doing something with it. BigQuery, you have to run the query first, right? You don't know when the message has arrived, so you have to kind of query. So it's for 2 different kind of things. But yeah, so this is very important. As I mentioned earlier, the subscription, you can see there's 2 things, right? You can consume it from the topic, but the reason by using a subscription is because you can specifically filter the one type of message you want to put into one type of BigQuery table with one type of schema, right? So that all aligns to give you very structured data. Okay, now let's go into the code examples, and then we can see how this actually works in action. So look at this page. So before I actually start going into the details of the code, the first thing I want you to run through is what I've actually done, right? And the code structure I've got in this repository. So start from the very top. So this is a thing I've created to use the cloudkafka.com service. The reason I use this one is that because this is the only place that you can easily create a free Kafka cluster, right? It's actually pretty decent. You get you can create your own topics and things like that, and then you can actually send messages to it and you can consume messages to it. So it's just like the real thing, but it's free. And this instruction here is you can basically just follow the link and create it, is to run this thing. It's very straightforward. The first thing you've got here is a sample message with the BigQuery schema. The sample message here is that it's really simple, right? So imagine this is something that you store in Kafka. And you would have, for example, in this case, is the JSON payload. It has a few columns and a few nested columns. So this is something that you have arrays in here, right? And then this then gets mapped into the sample BigQuery schema, which you see that has the transaction time, the first name, last name, list of products, which is repeated data, which BigQuery supports, right? And then it has these 2 columns. There's one interesting section in here that I've added, which is, this is really important because as part of the message consumption in the relayer, you can actually do a bit of enrichment. And the original message obviously doesn't contain the information on Kafka, right? But with additional metadata columns you add in here, you can put things like the topic of the Kafka, the partition, the offset of each partition, and exactly when this message actually landed on your consumer, right, in the relaying process. So this is really important, because once you put this data in BigQuery, you can use it for debugging, right? If there's a problem, you can see exactly at which offset, which partition, and which topic it got to. So when you fix your problem, you can easily see what you've got and what you haven't, right? This is really, really key. So back to the README again. In order to use this thing, right, you can use this the submit create table bash script. It's really simple thing. It's just the gcloud command that you can create the schema, you can create the data set, and you can create the table, right? On the configuration side, so for both the producer and the consumer, so I've got the two scripts on the left. You can see I've got a Kafka producer and a Kafka consumer. Producer, as it suggests, is the script that will send the data to the Kafka cluster for testing purposes, right? In your use case, you would already have those messages in Kafka. So this producer is just to replicate and then send this sample message I've got, and then add some data to make it a little bit different, right, on each message, so that we can track it on the other side when it arrives into pubsub and BigQuery. And also the consumer side is so this is the consumer, which is the relay, but it's still a consumer, right? It consumes data from Kafka itself and then relay the data into pubsub. So there's a number of because the way this Kafka cluster works is you will need to specify the username and password when you're using it, and then the brokers, these are the number of nodes you've got, and it has the 94 ports where you have to use to attach your consumers or producers, so it knows which topic you're using, right? And then this is the topic you have to specify and say this is the topic we are using to send the messages to or consume the messages from. So these are the key ones that you need to use. I've got a few, like a requirements.txt file, which is you can install the required packages, and then you've got the producer and the consumer code to run. So finally, you've got the Dataflow job that to do the submission, where you can submit the Dataflow job to consume messages from pubsub and then dump into BigQuery. So that's kind of the whole flow. What I've already done is I already set up the Kafka cluster. So you can see in here, right? I've got this topic here that is basically create this for you automatically by default. You can see there's 5 partitions, 3 replicas. That's basically just saying for every partition you have 3 copies, right? So it just basically then it gets distributed between different servers. If you lose one, you're not going to lose data. You've got retention, bytes, and retention milliseconds. Those are the ones, obviously, on this free one, it doesn't give you a lot, right? But it's more than enough for what our purpose here to do the demo. Okay, so to start with, I want to run through some code with you first, so I can explain how this code works. So it's a bit easier for you to read about it later on. So start with the consumer itself. Very straightforward. A few configuration file, and then the in here is basically all it's doing is you can see in here I basically read the sample message, and what I'm doing in here is I change the transaction time to right now as the ISO format, and then I kind of dump it into a JSON payload, and then I produce the message to the Kafka topic right on the cluster. So this is because I don't have any messages, so I have to produce some messages for this flow to show it to you. The most important one is this consumer payload. So this would it will take me a bit of time to explain. So first of all, this the consumer has 2 block of code that is mostly critical. One is the part that consumes messages from the Kafka cluster, right? So it has to get the messages back, and it has to manage the offset and all that stuff. Then it has the other part, which is to push the messages to the pubsub topic on the GCP side. There's few things I want to run through, which is important. So start from the very top. The callback function is whenever you make a call, right, to send the message to the pubsub topic, is actually creating, so the pubsub client that creates a future. So what future means is it's not actually a synchronous process. It's asynchronous. It runs in a separate thread. So behind the scenes, you basically say when the message has been sent, and then do a callback, right? You can see when the callback function is called. So it's basically when it's, you do a lot of construction of the message payload, and then you publish it. Then it goes into a future. You can set each future to have a callback, and then the callback, you do something about it. So that something is quite important, because when you call future.result, it makes a block within that thread. So there is a way you can check, there are ways you can check if all of these sent are successful, which I can show you where exactly that does later on. So it's very important that you call the future.result in this particular case. So there's some logging in here. You can actually enable yourself if you want to see exactly the message ID is actually sent to pubsub. There's a batch settings and publish options, and all of these settings in here with the topic, project and topic ID. So those are just the configurations for the sending part to the pubsub topic. This is important because I've tuned it to, you can see there's few things is important. There is the maximum bytes and latency that this is going to wait. So it's going to accumulate a number of messages before it sends to pubsub based on these criteria. These are the things you can adjust based on the latency requirement you need, right? So if you have so much traffic, setting these things to a little bit higher would give you better throughput. The other publisher options that the most important here thing is, so this is the flow control that it determines how much messages you want to send, right, to the downstream pubsub topic. So you can specify the flow control parameters in here, but one of the key things you want to remember, and by default is not set to this, keep this in mind, is you must set this to block on a production system, because if you don't set it to block, when there's too much messages you're trying to send, right, in the relayer, but you might not be able to send that much. If you leave it as default, which is ignore, and that means you lose messages, right? So the message would not go to pubsub, and it won't raise an error either. It's a warning like hidden behind the scenes. So this is really, really important to keep in mind, right? So that's pretty much about some of the important settings on sending the messages to the pubsub side. This is the main code block that we will pull the messages, which fetch the messages with a timeout of 1 second. So I put some comments in here in this section, but I'll come back to it because it will take a bit of time to explain exactly what this is doing. This is related to how do you reliably manage the offset of each partition's commit process. So this is something took me a while to work out, and also there's some references you can read in the README about exactly where this is coming from, the Confluence guides. So it's really important because this will ensure that you don't lose messages, because in other case you will. I'll come back to this later on. So in this while loop, after you fetch the messages, you would kind of get into this kind of main thing, right? If the message is not errored out, then you may run into this main block. So this main block is basically your message payload construction process. So this is the enrichment I mentioned earlier, that I wanted to add the metadata of the Kafka stuff. So you can see the message will contain the topic, the partitions, the offset, and here I've got the current timestamp, right, which I want to send it to BigQuery for future references when the data goes in. And then I've got the you have to encode the message into UTF-8. Then you can publish the message into the pubsub topic. So this is the callback we looked at earlier. That when something goes in, you can do something about it. You can also pass the metadata into this using this functional tools with partial function. So this allows you to pass additional arguments into the callback, right? This is kind of a very useful technique for this. And one of the key things you can see here is line 132. So this is where we append all of the futures. As I mentioned earlier, every time you publish a message, it goes into a future, which means it hasn't happened. It will happen at some point in the future. But we collect the futures. These are still objects, right? So, and in the publisher futures array, which we'll come back to on exactly how we're using that. Okay, this bottom big block of the code is how exactly do we manage the offset. So I'll go through a little bit more in detail in here. You've got the topic, right? This is where we construct the publish future offset trackers. We track this offset we say for this topic in the key, and then with this partition, and then we append, right, the current offset of this particular message. This is important because what happens later on when I run this whole process, I'll show you the logs. You can see this is more obvious exactly what this is doing. But in a nutshell, I'm trying to collect all of the offsets of all of these partitions in all of the topics I'm using. In this example, I'm just using one for it's easier to demonstrate. But the offset is collected in here, right, and then stored in this particular place. Okay, now offset management. If I just read this through to you, so you start making a bit more sense as we run through the code. So manage offset on each partition, right, and topic independently by making sure only the latest +1 offset is committed when all requests are sent to pubsub successfully. So there's a few key things in here. Each partition for the topic has their independent offset. Remember the diagram I showed you, just in here early on. So each offset, right, is attached to a partition for a specific topic. So when you only want to commit your offset if the pubsub send is successful. This is really, really key because the network can fail, right? The pubsub service can be down, although it's a highly valuable service, but it can still go wrong. A couple of times a year, it does happen. When that happens, do you want to lose messages? You probably not, right? For some of the less critical use cases, you probably don't need this complexity. But if you can't afford to lose messages, you need to make sure you do something like this, right? So when you commit the message, you make sure you need to commit the current offset +1 because that's where it positions the message to the next one for the remaining consumptions. So this block of code is kind of doing the whole thing, right? There's one important thing in the pubsub client is the message will be retried for a period of time. That you can change that as well yourself, right? So the message itself, if it fails for 1 cent or 2 cents, it will try it for a period of time before it gives up. I can't remember what the default is, but it does do that, and you can adjust that too. So this is basically the way to manage a some of the outage, but only lasts for a couple of seconds, right? This is what happens. However, you can see that in here that what I'm doing is if there is sufficient failures in this process, right, then I do not want to continue. I want to throw an exception and terminate the consumer process. So this is important. I'll walk through the code details. I'll come back to the what every part of this does. But it's important that I don't want it to continue if it's constantly trying and it doesn't work. I don't really want to handle the retry logic at code level because it's quite difficult to write that kind of code. It's easier that you just basically write a health check job and say if this process dies, just restart it, because that's the whole point, that your offset has not been committed, right, until the message is successful. If there's a lot of failures or even one failure, because usually it doesn't fail like this. If something fails, the whole thing fails, right, on the pubsub or network something, so everything is broken. Then this process will shut down, and then you can use a health check and some cron jobs and basically restart the process. It's quite easy to do that, right? So then you don't have to handle the retry logic at code level. Okay, now let's get into the details. The first part of this is basically, it basically means the futures wait method is that something that you can check, right, based on certain conditions and when it returns. So in this particular case, I'm saying for all of the futures we've collected, right, if I see one exception, then, because this is after the retries, right, still failed, and then I want to say, okay, from all of the done processes, do I actually have any exceptions? If there is anything, I want to kill the process immediately because there's no point, right? There's something even after retries, it can't do it. So no offset has been touched, and then it continues. So this block of code is all about, it's some really basic sorting to basically work out the latest +1, right? So you've got a lot of this stuff. The reason that I didn't just work it out in the previous process is because it's easier for debugging. So if something goes wrong, I can see exactly what offsets I've got in this array, right? And then I can see, here is which topic, which partition, and the offset I want to commit as well. And then I basically append this to the topic partitions. This is the final step that I use to update the offset. So there's one very important thing that I want to mention about this method. It's something that not really well documented. There's an article in here that you can go back and then find it on exactly where I got this idea from and why this is a recommended way to manage the offset recommended by Confluent. So this variable is something that I've actually to set a configuration first in here to make sure it does it properly. But in a nutshell, what this means is if you set enable auto offset store to false, right? So the way the Kafka consumer works by default is there's a thing called the auto commit, right? So it doesn't actually you don't actually manage offset, and that's actually a quite big problem, because if you try to send something to your downstream systems, right, and then suddenly it goes down, the offset could have been committed anyways. You could have been losing lots of messages in that process. But the way it works is there is a local buffer stored on your client side, which is where your consumer runs, right? And then that automatically by default store the offset and then commit it, right? That's how the auto commit receives those offsets. But this parameter set it to false, turn it off, which means you still have auto commit, right? But until I tell you this offset has changed, don't change it, right? This is exactly what it does in a nutshell. Now coming back to the code, this bit on the consumer.store offset is the thing that you use to update. But the way it works, it takes a number of topic partitions, right? This topic partitions is this class that you import. You can see at the top from the Confluent Kafka package, you have the topic partition. So this thing takes a topic, a partition, and offset that you want to commit, right? This is the three parameters or argument this class takes. Then you assign it to the offsets key. Then it will update the offset for the auto committer to commit that, right? This is really, really important, because what I'm basically saying here, if there are any failures at this step, I want to fail my process, right? And I've not made any commits to the offset. So this is really important, right? So when you update the offset, you always make sure that you've actually sent all of the messages to downstream systems before you update the commits. And then also the way that Kafka partition works, if you look at this diagram again, it's not the easiest. You don't actually get an ID that you can commit separately for each message, right? It's just an integer. So the way usually you commit the offset is it's like a sequential thing, right? So now you've got to 100, and then you have 50 messages, you go to 150, you commit, I've got to 150, right? You don't commit every single message, because that is a very expensive process for Kafka to the cluster to process. So you always commit periodically, right? But that the problem it causes is, if you commit for offset that is too early, then you have lots of duplicates, right? If you commit it too late, that if the message hasn't been sent, right, you committed the offset to be 150, then you lose the messages in the middle. So it's a quite complex process you need to manage, and that's why this store offset thing is really smart way to manage this thing. So you can actually make sure that your downstream process has actually finished before you run the code, and then after that you reset everything, right, and then it starts from the next batch, right? I know it's read lots of content, it's really complex, but if you want to run this on production, make sure you understood this properly. I've done some testing, but I'm not sure it's 100% sufficient. So test this yourself, making sure it works for your situations. But the logging is quite good, and now I'm going to show it to you to run it. To start with, you can see the code here. I'm going to start 3 consumers, right? So this is mirroring what we saw in the diagram earlier on. The reason I want to do this is so that I can show you there is no two consumer trying to be attached to the same partition, right? This is really key, so you don't get this competition going on the same partition or the same topic. So consumer 1 start, consumer 2 start, and consumer 3 start. So the code you can just, maybe a bit refactoring to make it look a bit better, but you should be able to just deploy this onto any virtual machines, right, in your environment to do this relaying business. So now we have the 3 consumers going on, right? So now I'm going to start running some producers to load some messages into the message queue. So I've got, like, these are the batches, right? As you can see here, it goes into partition 2 of this topic, right? This is the first batch, second batch, 2, 2, 2, 4, 2, 0. So this just goes into different partitions. That's kind of the process of logging, right? And now it's finished producing those messages. Now if you look at consumer 1, this is where it gets interesting. You can see that you've got messages 473, 74, 75, right? There it's just accumulating. You got to 477, and then when it does the commit, right, of the offset, you've got partition 4, and then offset commitment is the last one, which is 477 plus 1, which is 478, right? That's the message I've committed. And in consumer 2, so this one you can see is the partition 4, right? Consumer 2 is dealing with here you can see this is partition 2, right? 2 and then 2, so it was only dealing with one partition again, right? And then you've got 2 and then 651. So that's the last one, the last commit. And then it's actually pushed to the auto commit and say, now you can go ahead and commit 651 because I've got that message in pubsub. All of this message in pubsub. Consumer 3, you can see is dealing with zeros. This is the number 0 partition, and it got to 1483. Then it actually went to another loop. This one is 0 again, is 1498, which is the next commit, right, of the 1497. Right. So this now has been sent to pubsub. So this is the Dataflow job, and all it does is you point to the template, right, which template you want to use. I put a comment in here. I did this for simplicity, but when you're doing the using a template, you don't want to use latest, right? Make sure this is in a hash of the exact versions, because the latest can change, and the next time you submit, it can break your production system. So never use latest. You specify a job name, the project ID where you want to deploy it, the region name in there. I had to use a temporary use a different region to get around some resolving issues on the region. You've got the networking side, and then you can set this to your network. And there's also a few interesting things I've done in there. You got the disable public IPs. So this is an internal service between all on the Google network. There's no point in creating public IPs on your machines. So make sure that subnet is this is a private subnet, and you have machines that doesn't have public IPs. There's some escaping that going on in here, but basically you use this pattern to escape the names of these multiple parameters you want to specify. So you've got the tilde, which is what I'm using here to split. You've got the input subscription of the pubsub, right? And then you've got the output table specification that you put in there. So because this took a while, so I already submitted the job in here. So you can see it's currently running, right? So it's relaying. So this is taking data from pubsub and then putting into a BigQuery table. You can see the pipeline is quite interesting. So you've got the insertion, the streaming inserts, which I was talking about. Then you've got the failed records. What's happening here is, now I'm just going to run this query, right? You can see this is the target table I pointed to, the transaction with metadata, right? So you can see the previous attempt that I did in there. So I was trying to send it to transactions, right? This is the original table. It has a different schema. It doesn't have the metadata or anything like that. When I started trying to send it the schema that is not compatible, even you specify nothing when you're deploying the Dataflow template, it will automatically create an _errors _records table. So this is basically kind of like your BigQuery dead letter queue, right? And then you can see in the previews, you can see the transaction messages, right? This doesn't conform to the schema because I added a bunch of other stuff in there, right? And then also it tells you, so you can see this is all in the payload, and then it gives you the errors, you know, the details of the errors and the reason why it didn't work, right? This is really good because you always have the failed ones. So let's say if some of the messages or someone made a breaking change, right, in the Kafka topic, when it gets into BigQuery, you don't lose track of them. You can use this to easily analyze it, because if it's in the pubsub side of things, it's not easy to just, you know, find these issues and look at them and to correct the issues. But BigQuery gives you this insight, and you can plug into dashboard and then even set up alerts back into the upstream systems or teams, telling them, oh, there's a problem in there. You've got errors in your pubsub, in your Kafka topic with the messages in there. But this second one is the one, you know, where I have the additional metadata columns, right? So if I run this query, you can see, right, this is where it gets interesting. I've ordered the messages and broke it down into the topic name and partition name and the offset. So you can see the transaction time is different and the consumer timestamp is different, right? This is the last batch I've sent. Let's go back to, let's have a look at some of these offset, right? So the Kafka offset, the latest one, you can see these are sequential because Kafka, each partition, the message is always ordered by this offset keys. So you've got the partition here, which is number 2, that is 650, right? You've got the Kafka partition 0, which is 1497. If you look at the logs, right, we've got from early on, in the consumer 3, we've got partition 0, the latest is 1498. Keep in mind the committed offset is always +1, right, to the latest. And here you've got 1497, which is just the one before. That is correct, right? All of these messages are there, and then we just, you know, committed all of these messages. And then on the other side, you've got you know, all of this data. So you can see this is the preview. We can look at the latest, right? Just got in, and then these are here, right? So you can see all of the messages with the metadata. So that's all relayed from the Kafka side. You can see the details here. You've got the streaming buffer as well. This indicates it's the streaming insert that we're doing here. It's not kind of a batch. So let me show you more things. So if I go to the producer, right, and then I run this stuff again, see I'm delivering more messages. These consumers are running again, right? Each one of them, see, it's consuming more messages, as consuming more messages, right? I go back to BigQuery. See, the latest one is 2307, right? You see, this is here right now, right? That's real time. Yeah, not the milliseconds, but within a second or two, you get the data in here. So that's, yeah, that's the latest. I think it's probably finished committing. So now, yeah, you've got the partition 3, 1539. Which one is partition 3? 1540, right? So it's just the one out. Yeah, so this is how you manage it. Most importantly, right, if I kill those consumers, 1, 2, 3, right? After this happened, the offset is not gone, right? These are committed on the Kafka cluster itself. So for each, it's called the consumer group. So for each of those groups, it has the actual committed offset is stored on the Kafka cluster itself, right? This is really important, and that's why the committing the correct offset is important. When I restart any of these consumers, right? So now I've restarted it. Have you noticed something? It's not doing anything, right? It's not doing anything. And that is important, is because the offset is not incorrect, right? If the offset is incorrect, it will start from the, you know, maybe if I committed the too early offset, it will start from the earlier one. If I committed too late, it will lose messages. But then if I try to commit messages again, right? See here, now this has sent partition 1, 0, and 1 and 2, right? So in here it's dealing with, now I've just started one consumer. You can see this is dealing with all of the partitions we're dealing with here, right? And it started committing again. You see, this is why the debugging is useful. You can see where it started from, right? From number 1 is the last one, 612. I can't easily see it from here, but I have tested this quite extensively, so you can see all of the details in here. And then finally, if you look at these ones, you've got the data is pushed to the other side, and then the latest for number 4 is 494, right? So 495, that's just 1 out again. So yeah, you get the idea. So this is actually working quite well for me. So it took a while to tune this stuff, but this is like a really important, and this stack is so powerful, and it's really easy to deploy this to your on-prem or to your AWS, to kind of the the other ecosystem that you just want to relay the data from one place to another. With Kafka, the important thing, the reason this session is a lot longer than a normal session is because I really can't explain this in a short period of time, because it's not going to be very useful to you if I just rush the whole thing. So that's why I had to spend quite a bit of time on each areas, just to give you enough details that you have to understand. Especially, so this is the most important part, right? How to handle the offset using this technique. In the README at the very bottom, you can see these are, I'll put it in the YouTube description as well, the video description. You can see these are the links. So I've improved this repository from the original solution that the Cloud Kafka guys did, but they didn't actually use. So that version is more of a you will lose messages version, right? So if something isn't working, that you're not sending to downstream systems, you will lose those messages, right? So but this version is the modified version using this idea that from this one of the GitHub pages, right? This is actually a someone submitted a how do you manually commit only after successful message production, like sending it to downstream systems. So it's a very detailed read, and it took me a while to find out where the function is, right? Because it's not very well documented. But this is why I put the code together and then tested it quite extensively, so you can see that exactly how to handle this kind of situation. Yeah, it's just the way the Kafka offset management, the way it works. So it's not the easiest thing to work with. But once you have something like this, which robustly manage when you update the local version of your offset buffer, right? And then it will only push it, the auto commit will keep doing it. The auto commit by default is 5 seconds, right? You don't want to change that to too low, because it puts a lot of stress on the Kafka cluster itself. But with this thing that you can manage exactly when you want to commit, right? Keep in mind that Kafka is the same as pubsub. It's not a exactly once message system. It's at least once. So if something dies before you commit the message, when you restart, it will still be on the previous offset, right? So if everything works perfectly, then you would never run into any of the issues. It would never have duplicates, right? But that's never going to happen in real life. So whenever you have these network issues or these other issues, then you would have message that comes through on the other side with duplications, and that's expected. But you never lose messages, right? This is the really key things that you need to remember why we're doing this this offset management in detail, and why we covered this on exactly how this works. Okay, that's the end of this session. Hopefully you're not too exhausted, and thank you very much. I'll see you next time.
Go out!